Okay, so I wanted to show you some other cool things about parametrics, and one of them is to show you how to do these on your calculator. So if you are following along on your calculator, you want to get your calculator and also maybe write these down so that we can put them in our calculator. I'm actually going to write them down too because I forgot to do that before we started. And I just want to show you a little bit about what makes parametrics the way they are. One of the things people like about parametrics, well, people being mathematicians, is um, that they're still functions. Mathematicians really start to love functions. So when you have circles and ellipses and hyperbolas that are not functions, but you want to define them as such, you can use polars and parametrics to do that. So the beauty of functions is they can work like computers. Computers, when they started out, you could only plug in something and get one number out, and that's the idea of a function, and that's the beauty of this. Okay, hopefully, I guess you can hit pause now. I don't have to wait for you to write these down to switch over to our calculator. Okay, your calculator does have a parametric mode. So it's down here under mode. Last time we changed it to polar right here. So if you see there's functions, that's the one you've used for most of your high school career. And we are going to switch it to the second one. The fourth one is to graph sequences like we did whenever we did sequences. I feel like I can't even remember, but you could graph them. It's kind of boring. That's why I never showed it to you. But this will do parametric. Now, when you go to the y equals screen, you'll see that it says x1t, y1t, and then x2t. So it sets it up in polar form for you. So the minute you hit that x comma t comma theta comma n button, it's a t instead of a theta or an x. So this is the part where I'm sad that I'm not teaching you because everybody's excited that there's a reason that there's four variables on that key once you learned that in pre-calc. So let's make sure we can graph this all correctly. So I have cosine of t, sine of t. Let's see if when I graph it, it comes out to be anything. Oh boy, I think it's going to go extremely slow or we can't even see it. So let's change our window. Let me go back before I change my window. Let's go to mode and see what I'm in. I'm in degree mode. So let's go back to window. And right now, if you look at my T min and T max, my T max is 6 degrees. I want to go a lot farther than 6 degrees. So let's go from 0 to 360 and let's go by 1 degree. My X min and X max, let's just do negative 10 to 10. And then we might scale that up or down depending on what we want to do. So now when you graph this, now it should turn out, it's going to look a little elliptical, but see how it's going through 1, 0, 0, 1, negative 1, 0, and then 0, negative 1. That would mean that this is a circle. So I think I showed you this in a previous one. If you want it to not look like a circle and you want it to act, or I'm sorry, if you don't want it to look like an ellipse because it's actually a circle, you can hit number 5, which is zoom square, and that'll actually make it look like a circle because the X's and Y's were different size. Okay. Did I put a 4 out in front of there? I don't think I did. Let's change that real quick to make that 4 cosine t. I thought it was a really small circle. The beauty of these videos is I'm not really editing and starting over and pausing and restarting a slide. We're just going to go with the flow like I would in class. Okay, now we've got a much bigger circle, but it looks nicer. Keep going. If you changed it to do a t-step of less than a degree, maybe like every 2 degrees, this would move a lot faster. Or every 5 degrees, it just wouldn't look as circle-like. It would only plot every 5th point or something like that. Okay, so if I change this to a negative t in here, let me just show you what happens. Right now, you should be thinking about what happens when you do that. What is that going to do? Is it going to change the shape? What's going to happen? And if you look, you had to pay attention to which way that one was graphing. That one was graphing in like our normal unit circle. This one is graphing backwards. So that negative t makes it graph in the opposite direction. And then if we were to change it to 3t, and hit graph, Hopefully you can see what it's doing. I'm not sure you can tell, but it's graphing it a lot faster. It would be, if you're talking about time, you would be moving around this circle a lot faster. You'd be moving 3 times as fast as you would if we were just had t. So hopefully that explains a little bit about parametrics and what's going on.